All right, network edge is locked down. Now we turn inward and harden the host itself. Lesson 15 puts 3 universal Linux primitives on the table. Sudo for least privileged command execution, PAM as the unified auth fabric behind every login and sudo call, and sysctl for the kernel knobs that shape network, file system, and process behavior. By the end, you'll know exactly who can run what, how each authentication decision is made, and which runtime defaults you should never ship without changing. Starting with sudo, and the first rule is never touch sudoers with a regular editor. Always use visudo because it validates syntax before saving, and that single check is what stands between you and locking root out of the box. On Ubuntu, membership in the sudo group hands out full root with a password, which is fine for a workstation, but way too broad for a fleet. The production pattern is drop-ins under Josh etc. sudoers, D, 1 file per team or service, scope to exact commands. Memorize the grammar. Who, on which host, as whom, with what tags, running what. And remember those files must be mode 044 or sudo silently ignores them. Now the real patterns. Pattern 1, CM and alias lets you whitelist exactly restart, reload, and status for Nginx, nothing else. Pattern 2 is the ruinous trick. Dev sudo to www data, not root, so a compromised deploy script can't escalate. Pattern 3 tightens the defaults. Timestamp, timeout down to 5 minutes, required and use potty, so every session lands in the audit log. And pattern 4 is the bang dangerous pattern. Full sudo except shell spawning binaries, because letting someone sudo bash defeats the whole point. From sudo we pivot up the stack to PAM, the framework every login on this box already consults, whether it's SSH, SU, Getty, or sudo itself. Think of it as 4 phases stacked per service. Auth proves who you are, account decides if you're allowed in right now, session wraps setup and teardown around the login, and password governs how credentials get changed. The control flags are where the real logic lives. Required keeps evaluating to hide which check failed. Requisite bails immediately. Sufficient short circuits on success, and optional is informational only. Get those flags wrong and you either lock yourself out or leak which factor broke. Last stop in the local host trio, sysctl, the kernel's runtime tuning surface. There are roughly 1,000 knobs exposed, but only about 20 actually move the needle on security, and most ship off by default for backward compatibility, which means a stock Ubuntu box is softer than it should be. Drop this file into chushai etc. sysctl di99 hardening.conf so it survives upgrades, then apply with sysctl. Every line here earns its place. Forwarding off unless you're genuinely routing, reverse path filtering to kill spoof sources, ICMP redirects and source routing disabled to shut down classic MITM vectors, SYN cookies verified for flood resilience, and Martian logging on so you have forensic breadcrumbs when something weird hits the wire. Now we pivot from wire to kernel. KPTR restrict and dynamesg restrict starve local exploits of the addresses they need to land payloads. Yamup trace shear scope blocks one process from injecting into another, and disabling unprivileged BPF closes off an entire class of 5.x privilege escalation bugs. On the file system side, the protected hardlinks and symlinks pair shuts down the classic TMP race that's been burning SysAdmin binaries for decades. Suid dumpable off and core pattern piped to bin false means a crashing SysAdmin process never leaks secrets to disk. Apply, then grep to verify. Never trust a knob you haven't read back. Here's the catch though. None of this is one size fits all. Flip IP forward off on an LXD or Docker host and container networking dies instantly. Turn PD race charm scope to 2 on a developer box and GDB strace and every eBPF tool stops working. So match the profile to the role. Bastions and internet-facing app servers get the full stack. Databases skip the network knobs. Container hosts keep forwarding and unprivileged BPF on. And dev and CI machines relax the debugger restrictions. Drive it all from Ansible group vers in L20. Never hand edit per host. Now, profiles in Ansible mean nothing if the running kernel disagrees with what's on disk. Config is not state. A drop-in can have a typo. A later file can override your knob. A sysctl can fail silently at boot. So verify. Sudo-u tells you exactly what a user can run. PAM tester dry runs an auth attempt without locking anyone out. And diffing sysctl, system against your hardening conf catches drift instantly. Then let Linus score the whole box. Baseline Ubuntu sits around 70. This lesson pushes you past 90. Run it weekly in CI. Auto-open a ticket on any 5-point drop. Now everything you just saw, sudoers, PAM, sysctl, is the essentials layer. Real hardening goes deeper. Audity capturing syscalls at the kernel boundary, AIDE catching file tampering, USB guard for physical access threats, module signing, lockdown mode, the full secure boot chain. That's a separate 13-lesson course on Dargslan.com. Linux Hardening Mastery with 20 production sudoers templates, 50 sysctl knobs mapped to CVEs, and compliance crosswalks for CIS, STIG, and SOC2. If this lesson sharpened your appetite, that's where you go next. Before we wrap, 5 gotchas that will absolutely bite you in production. Number 1 is the classic. Hand edit sudoers, miss a comma, and every sudo call now returns parse error. You're locked out. Always use visudo. It validates before saving, and keep a second root shell open while you edit. Same energy on the drop-ins. Wrong perms and sudo silently ignores the file. Ikmod wallo for Rio. Owner root.root, non-negotiable. PAM typos kill sysctl logins, so test from a second session with console recovery ready. sysctl belongs in, etc. sysctl.d with a high prefix like 90 hardening.conf because conf.d loads last and last writer wins, and run Linus weekly in CI. Upgrades silently revert kernel knobs, and you don't want to find that out 2 hours into an incident. So that's lesson 15 in 6 skills. Sudoers dpatterns with CM and alias and tight 0440 perms. Production rules scoped per role with explicit deny lists. The PAM 4-phase mental model. sysctl hardening across network, kernel, and file system. In a Linus-driven audit loop catching drift weekly. That's your local privilege surface locked down. Next lesson, we layer App Armor on top. Ubuntu's default Mac, per process sandboxing, so even a compromised binary running as root hits a confinement wall. Privilege layer, locked. Sudoers, d, PAM stack, sysctl hardening, Linus audit loop, all 4 checkboxes green. Next up is App Armor, why Ubuntu shipped it instead of Linux, profile anatomy with path-based rules, complain versus enforce for safe rollout, and genprof to bootstrap profiles from real workload traces. That's also your bridge into container hardening mastery. See you in lesson 16.